All right, a 78 kilogram, that's a mass, skydiver, has a speed of 62 meters per second at a height of 870 meters above the ground, okay? 500,000 joules of energy are transferred to thermal during the fall. Wow, that's a lot, ETH. With what speed will the skydiver hit the ground, okay? So here is the skydiver. That does not look like a person. Okay, so let's see. So the position A would be the top, right? I guess when it's 870. And then with what speed will the skydiver hit the ground? Wow, I guess, did the parachute not open? This is a pretty bad problem. So, okay, I guess, yikes, I guess he's hitting the ground with some speed at the end. Maybe it shouldn't be a skydiver. Maybe it's like a box or something. Let's change it to like a box. Okay. All right, so let's see. Either way, let's see. He is above the ground. So yes, there's going to be EG. He's moving at the top. So that's going to be EK. All right, there's no spring, stretch, or compress, and there's never any thermal in the first part. Okay, so let's go ahead and solve for these. So the mass is 78 kilograms, the G and the H is 870. So, oh my God, how did the pencil die? Oh no, it didn't die. EG equals, okay, let's see what we've got here. 78 times 10 times 870. 600 joules, okay? And there's also kinetic energy because he's moving. So 1/2 times the mass was 78, and the V is 62 squared. Okay, don't forget to square it. That's what a lot of people do. So 0.5 times 78 times 62 times 62, 149,916 joules. Okay, so if I add that to the EG that I had, that's going to give me a total of 828,516 joules, okay? So that was this plus this totals up to that, okay? All right, so I still have that amount of energy at the second position, all right, because that total is going to transfer over, okay? And let's think about if we were going to do this. Let's go like 200, 400, 600, 800, a million. 200K, 400K, 600K, 800K, and a million, okay? All right, so if the total is 800, 678 for the EG is gonna be like, oh, I don't know, around there, 678, 600, and then the EK is kind of small, under here maybe-ish, 149,916, okay? All right. After he has no EG because he's on the ground. Yes, maybe, I don't know what happened to him. All right, is he moving? Yes. No springs, and 500,000 joules were dissipated due to friction. 500,000, okay? All right. Okay, so if I want to know how fast he is when he's at the ground, okay, so if that was 2, 4, 6, 8, 10, right, 100K, 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 100K. 500,000 are going to go to the thermal category, okay? And I had like 828 total to start with, okay? So then that means left, so if I had 828,516 to start with, minus 500,000 to end with, okay? That's going to mean my EK now is 328,516 joules. This was 500,000 joules, right? Okay, because this minus this is going to be the leftover amount is going to be the kinetic. All right, so 1/2 mv squared. I'm going to isolate for the V again. Okay, and then I'm going to get 2 times 328,516 joules divided by the mass, which is 78 kilograms. Okay, I'm going to move this down a little bit so I can have some space here. Okay, and that means my velocity times 2 divided by 78, and then don't forget to square root it. 91.8 meters per second. Yeah, so let's pretend that's not a person hitting the ground at 91.8. That's a little intense. But, I mean, I guess if the parachute didn't open, there we go. Okay? All right. Good on that one.